Alright, hello, this is Renee. On this project for the Fundamentals of Aerodynamics course with Dr. Ozbay at UCF, I worked with Otis Campbell and Pranav Kumaran Rajman. I'm taking the bonus ANSYS Fluent part of this project, and my other two group mates, they handled the XFLR5 part of this project. So, first things first, if you read this, we're just doing a 2D simulation, and then we're told our air density, dynamic viscosity, and all the other cool stuff. First thing we need to do though is we need to go grab a NACA2415 airfoil. So you want to look up NACA2415. Once you're in there, head over here to this first link. You grab that, change this to 200 points, close the trailing edge, and then plot that. Make sure you hit plot, and then you can come over here. Now we're just gonna copy everything here. Alright, boom. Control C. If you want to change chord length and other specifics, just go here to this website or link, and there you go. But now we're gonna open up Excel. Just gonna delete everything I have in there. Control V, paste, get rid of this first row. Take this, move that over. Alright, and then this first column, our X points, we know this is X because our airfoil is a meter long. There we go, so it's a hashtag X, and then for Y, we want hashtag Y. For Z, hashtag Z, like so. And then for our other points here, we want to have hashtag point and hashtag group. This is all for ANSYS to read. Group, groups is going to be the same. All of this is going to be set to 1. Just drag that down. So, boom. Go back up here. For points, we have 200 points that we're going to start at 1, then we go 2, then we go 3. And then to make this easier on ourselves, we make our little formula here, equals, click the cell above, plus 1. Drag that filler down. Boom. As you see, we're at 201 points. We're going to fix that a little later. And then when it comes to the Z over here, since we're only working in the XY plane, Z is going to be 0. And then you do that right there. Boom. Alright. And then if you import this as a CSV file doing the other method that I showed you, will have other stuff. Just delete that, as we do not need any of that. And then for this last point here, where it's attempting to close our airfoil, we are going to actually get rid of that right there. And then once you close that up, you just want to change this to 1 to 0, like so. Alright, and now when you have this Excel file, let's head over here, File, Save As. I'm just gonna save it in my class folder real quick. Call this NACA2412. And then over here you want to save that as a text tab delimited text file. Boom. Save. And then you're good. Don't even worry about that. You're done with this. You can go ahead and close this. I'm gonna minimize it for now. Alright. Don't know why that was open, but anyway. Alright, so now let's get into Fluent here. So when you're in Fluent, what you want to do is head over to Fluid Flow, Fluent, double click that. Alright. And then before you use your geometry, just go ahead and right click that and go ahead to Properties. This will pull up, change your analysis type to 2D, just so you don't run into any issues or whatnot. And then you can go ahead and open up Design Modeling. Alright, so once you have Design Modeler open, you can head over here. We're going to look at our XY plane. First thing we want to do is we're going to head over to Concept, and we're going to hit 3D Curve. And then right here, Definition says From Coordinates File, that's what we want. So we go over here, hit that, and now we're going to find that. So I'm already in the folder. You just find your folder, and then boom, this is the file I want to work with here. So I'm gonna open that, and as you can see, my airfoil has been imported right there. Before you continue, go ahead and hit generate, and as you can see, we have the airfoil in there. For some reason, ANSYS looks super shiny, but anyway, we can see the airfoil. I'm gonna go ahead and fix that. Let's see here. So next, we want to turn this into a surface. So we already have the curve that we want to surface. So we go to concept, surface from edges, and then just click on that, and then apply. And now we officially have that surface. Hit generate. Here we go. All right. And then now it's time to actually get into sketching. So we're gonna go back over to the sketch tab, and yeah, we're just gonna dimension our area from here. So first things first, we're gonna grab our arc by center. Make sure you see the P telling you you're aligned with the center there. C for that line, C for that line. And then we're gonna dimension this really quickly. We want this to have a radius of 7.5. Let me zoom out a little bit here. Like so. Then we go back to draw, we grab line, and then we're gonna have a line going across here. Make sure it says H so you know it's horizontal. Dimension that to 15 meters. Then we're gonna go back to draw, and we're gonna have a line coming from here. Make sure I see the P. Center there. And then boom. P, and then the C, so I know I'm aligned with that line. It's telling me it's horizontal as well. And then P, the P, and it's vertical. Alright. And then that is pretty much our like domain or whatnot. 15 meters, H, R is 7.5. Like so. And then now, the next thing we're going to get into is making actual lines closer to the airfoil. Because we want to finer results around the airfoil itself, we're going to add a couple lines there just to make this smoother for us. So we're going to touch right there. We're going to come here first, draw a line going up. Now we know our airfoil is 1 meter long, so we're going to dimension from here to here. Oh, let's select horizontal. Boom. And then we change this dimension to 1. And then we're good there. And then modify. I'm going to extend this so that's solid there. And then we're also gonna go on this side here and make sure you draw that line coming down here. VNC vertical, and it's telling me it's center with the line I have above, which is what I want. Boom. Alright, and then I'm gonna also come over here and draw another line, center along this line here, like so. This is just gonna be another line to have kind of at the front of our airfoil. I'll show the video I follow. He does a NACA2415 airfoil, and he takes this dimension right here to be, I believe it was 0.08, something like that. So, dude, it's like, what? 80 millimeters or whatnot, right there. You can mess around that, feel free to. But I'm gonna follow that. So that's what we have that line there for. Extend that. Go back to draw. Line. Point. And here. Make sure you see the C. Boom. And then that's that. We have our 2 lines there. The reason why we're setting this up is because we are going to do a face split, which will help us separate each of these faces that we're creating. So yeah, after you do that, now you're pretty much ready to go ahead and create an actual surface. So concept, surface from sketches, course, we're actually gonna do some lines from sketches first. You're gonna delete that. Concept, lines from sketches. Sketch 1. Apply. Boom. In there. Oh. Alright, I'm gonna do concept. After that, generate cool story. Concept. Surface from edges. Edges are selected. So we have 1, 2, there's a small one, 3, 4, 5, 6, 7, 8, and 9. And then you want to go ahead and apply that to your surface, generate. And then once you do that, you want to come down here, make sure you have that surface selected. ANSYS automatically define this as a solid, but we're working with air. You know, if we have airfoil, we're not flying inside of something else, we're flying in air. So we're gonna make that fluid. Boom, hit generate. Alright. And then once you have that, the next thing we want to do is make this airfoil actually, you know, something separate from our sketch. So you come over to create, you go to Boolean, and instead of unite, we want to do a subtract. So our target body is going to be this guy. Apply that. Tool body is going to be here. Right now it's selecting the front surface. I want the one in the back, the airfoil. So I select down here, like so. Apply that. And then yeah, generate, like so. We pretty much have our airfoil cut out there. Like you see, if I select the surface body, you see we actually cut out. So now we'll analyze what is happening around that particular curve we have there. And then I'm just gonna take a sneak peek at our airfoil here. Alright, so yeah, that is pretty nice and closed. It's a plus of doing multiple points. But yeah, anyway, let's keep it going here. Alright, so next thing we're gonna go do is we're gonna go ahead and get our face split going here. So we'll go over to tools, face split. What do I want to work with? This, and then yeah, that's the target face. And then okay, what do I want to split? So I'm gonna split by, make sure you have edges selected up here. 1, 2, 3, 4, and then the x-axis in the middle. And then you're gonna go ahead and apply. And then you want to generate that, and then you can verify this by hitting faces, and you'll see you have 1, 2, 3, 4, 5, 6 faces, which is what we want. And then to avoid some issues or whatnot, what we're gonna do is we're gonna go ahead and merge some lines here. As you can see, we have this really small line. You know, ANSYS is prone to crash out. We have that, so what we're gonna do is we're gonna go over here to our tools, merge, and then we want to merge this line and this tiny bit here and apply that. And then we're gonna come down here and do the same exact thing. So again, tools. Oh, let's generate this first. Tools, merge this guy and that guy, and then apply that. Generate that. All right. Let's see what we have here. All right. So once you have that, you're pretty much good to go with Design Modeler. We can head back over here into our interface or whatnot. And what I like to do is I like to update the mesh first to get that going over there and whatnot, and then we'll see how that transfers over. When that's going up, we'll go ahead and get to hitting edit and whatnot. Alright, so when the mesh is open, there's a couple things you want to go ahead and do. So orient this towards our X and Y plane. And then we want to go rid of geometry real quick. Line body, we don't need that anymore, so we're just going to suppress that right there. And then yeah, we can pretty much go ahead and start getting into the main bit of this. We're going to be working with edge sizing and whatnot. So if we come over here, you right click on mesh, you go insert sizing. And then we're just going to do some general face sizing here, or edge sizing and whatnot. Click these. So that's 1, 2, 3, 4, 5, 6, 7, and then right here in geometry, apply that. Change from element size to number of divisions, and then you want to turn off curvature, and then leave behavior as soft. And number of divisions, we're going to do 250. And then right down here, we're going to bias type. We want bias here. Click the first option, bias factor. We're going to go with a 50,000 here. 50,000 bias factor, and then we're going to zoom in. So the whole point of this simulation is we want to see what's happening around the airfoil. So right here you can see I get more divisions as I get closer to the airfoil, which I want. So I have to flip some of these around by doing reverse bias. So I come down here, select this, holding control. I'm going to select all the ones I want. All of those will flip around. So you see they kind of disappear there, but don't worry about that. It did exactly what we needed it to do. That is the main thing there. Now we're going to come back and do some more edge sizing over here. So 1, 2, and 3. And then we're going to apply that, change that to number of divisions. We're going to go with 150 here. And then we want to change our curvature to no curvature. We're going to run hard behavior this time. Bias factor on. This time we're just going to run a bias factor of 300. And then as you can see, I need to reverse bias again on these two as I want to analyze things as I'm closer to my airfoil. So I hit that, flip those around. As you can see, closer to the airfoil, we're finer now. More divisions, more elements, more nodes, all that cool stuff. And then we're going to add some more sizing on here again. Alright. So this time now, we're going to hit the nodes in the middle here, this guy, top of my airfoil, bottom of my airfoil, and this one. And then we're going to apply that. It's 4 edges. Change this to number of dimensions. No curvature. Number of divisions. We're just going to run 150 again. And then this time we're not going to worry about the bias factors and whatnot. We're just going to run hard behavior. And then one more edge sizing here. We're going to get the curve here, zoom in on my airfoil, that little front piece there. And then if they'll let me, that bottom piece as well. So that's 4. Change that to number of divisions. I'm going to run 100. And then take curvature off. And we're going to run hard behavior on that. Alright, and then the last thing we want to do is add some face meshing. So for here, just hit Control A, like so, apply that. And then yeah, we're good to go ahead and generate. This face meshing right here tends to throw an error. I'll see what happens during this round, but for the most part, I've realized that you can still move forward even with this error. It says there was an issue with matte meshing. As long as your mesh looks like this, you're good to go. You don't need to worry about this. I've tried messing around with uploading the airfoil using different points, moving these lines in different places, But basically that matte meshing error, it's something to do with the faces. You need only 3 to 4 faces for matte meshing. It's possible here it might be counting another due to the sharp edge, I'm not sure. But all I know is this is how my mesh should be looking. I want it finer here so we can see what's happening behind the airfoil. Right against it as well, you see we have very small divisions as we get closer, which is perfect. Beautiful mesh. If you're worried about how many nodes and elements you have, you can come down here to statistics and you see we have over 200,000. So cool stuff. Alright, before you leave the mesh, there are some stuff we need to define. So we're gonna make sure we have edge selected. We're gonna select here, 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 and here. Hit N on your keyboard. That brings up, that'll be our inlet. Come over here, hit these 2 lines. That'll be our outlet. And then we're gonna zoom in here. Select all of this. 3, 4. Hit that, and it's gonna be our airfoil. Alright, we'll hit generate for kicks. Let's go back here. Let's update the mesh. Yeah, do not forget your name selections. Don't forget that. Alright, when that's updated, we can now go into setup, edit, double precision, force solver processes, start. Alright, so when that's open, now we're just gonna head over here. We check everything, we're good there. Viscous, we're gonna leave this as SK Omega. I'll put the video in the description, but what I followed, they use this, and when I used KEpsilon, I ran into errors. There was probably an issue with my mesh though. Feel free to test that out. For my materials, I'm working with air here. For my project, I'm told my density is 1.2, dynamic viscosity of air is 1.8 times 10 to the negative 5. Change this right here, it's just 1.8. Let's do 1.2. Change create, close. And then we're gonna go over here to our silicone conditions. Boundary conditions, inlet. Like I mentioned earlier, how I found the 15 meters per second. But what we want to do is change this to components, as we're going to be measuring different angles of attack. It's going to be easier to define that this way. So right now we're just working with 15 as we're at 0 angles of attack. I'm going to show 0 and 10 degrees angle of attack, and then from there it's pretty intuitive how you set everything up to get your coefficient of lift, coefficient of drag, and whatever else you need. So we're going to apply that, and then let's just check the airfoil out here. Cool stuff. Make sure our reference value is set to inlet. This is very important. Make sure that is set to inlet, or else it will skew your results. Let's head down here to report definitions. We're gonna hit new, force report, drag, and it's set to drag coefficient right now. Leave it like that, and then 1 and 0. It's perfect. Print the console. Select airfoil. Okay. Report definitions. New. Force report. Lift. Airfoil. Lift underscore coef. Print the console. And as you can see, these are the values we'll be changing as we change angle of attack. So at 0, we're good here. Hit OK. Come down to initialization. Initialize that. And there's one more thing I need to be doing here. It's with my residuals, if I can remember where it's at. Right here we go. Edit 1e -6. Take that, drop that there, drop that there, drop that there. So we have more accurate data here. Boom. Head back over here. I'm gonna initialize one more time just for that. Yep. Alright. Go, come on. Alright, initialization is done, so now we're going to double click run calculation. we're gonna do 1,000 iterations. For the lower levels angle of attack, it did tend to converge much before that, so we're not gonna worry about that. And then yeah, we can go ahead and just calculate now. I'm just double checking that I did not skip anything important here. Oh, we're good to go. And then we hit calculate. Do have a lot of background stuff open here, but we should be good to go. Yeah, I don't even worry about that. It's gonna do this thing. I'll be back when the calculations are done. Alright, so I'm back. Calculation is over. As you can see, it only took 90 conversions there. Sometimes it does take a minute. That's why I just decided to, come back a little later and show y'all what I got here. Alrighty, so first things first, you want to see that velocity and pressure plot. So graphics, contours, new, Velcon, right here, pressure, velocity, not density, velocity, and I'm gonna leave that as velocity magnitude. I'm gonna compute that, save and display. Boom. There we go. Change this over here to a nice float value, and then if we just zoom in on that there, you can kind of see, we got our, you know what that is. That's our little stagnation point. Come on now, max pressure, and then we have this line here. We got our flow going over, and then we zoom in, no slip condition, putting in work right there. We got our, whatever you want to call it, your flow separation business going on there, all your cool stuff. But yeah, let me go over here to our contours and static pressure compute, display that, and then like we said earlier, that's our stagnation point. So lowest velocity, maximum pressure, or really no velocity there, but hey man, you guys know what I'm talking about. So there we go, boom, cool stuff. While I'm at it, I'm actually gonna take a picture of these. This actually came out a lot better than what my current photos look like in a document. If you see what I'm talking about here, I have these these cool like vortex lines or whatever. Might actually keep it, but hey. Anyway, get this velocity back real quick. Save display, boom. And then here we go. Bam. Alright. And then now we also want our drag and lift coefficients. So instead of coming down here to reports and doing a force report, we can basically just use what we set up earlier with report definition. So if I come over here to drag coefficient, I hit edit, I hit compute, it'll drop that number right there in my screen and specifically tell me that it's coefficient of drag. It's just a little bit easier than using force reports because you don't have to figure out what exactly ANSYS is showing you. It tells you directly here. So I'm just going to compare that with my value I got before. And yeah, it's pretty much the same. Last time I did this, I got 0.012035, and now I got 0.01207. That's probably because I actually did more points in the airflow, so it's a little more detailed. But if you run it over and over, it'll converge to a different value. But anyway, take that value, put it in your Excel sheet, do your thing with that, document it, whatnot. Now, I actually, for some reason, call this the life coefficient. That's not a thing. Let's change that. Go back over here, edit that, compute, and now I got 0.1906. Comparing that to my other value when I did this, I got 0.1912. So once again, this is a little lower, but they're pretty close to each other. Only thing I would say matters the most is these first 3 or 4 decimal places, so pretty close to each other there. And then yeah, so now when it comes to angle of attack, the main thing you want to focus on is that cosine. I don't have a diagram, but we know lift is vertical and drag is horizontal. So you can pretty much make your triangle based off of that and go from there. But for 10 degrees of angle of attack, these are the values I'm going to be working with here. I calculated my x and y velocity, cosine of that, sine of that, and then it's going to flip depending on if I'm working with lift or drag. So I'm going to go ahead and show you guys what I'm talking about. But first thing I'm going to change is the inlet velocity here for our simulation. So like I said, for 10 degrees angle of attack, 15 cosine 10, boom, 15 cosine, sine 10 degrees, get this guy here, apply that, and then you'll actually see in the simulation that one stagnation point, you'll see it move, which makes sense as we change our angle of attack. And then yeah, now we come down to our drag coefficient, and in the x and y positions, you're gonna put the cosine of your angle of attack or your sine angle of attack. So for our drag, this first box here is gonna be cosine 10 degrees, and then this one is going to be sine 10 degrees. Hit OK. And now for lift, that's gonna flip. This first box is gonna be negative sine of 10 degrees. So negative, drop that guy in there, and then the y is going to be the cosine of 10 degrees. Hit OK. I got that. Alright, so now same thing again. Make sure you initialize that and 5, 4, boom, 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 boom. Initialize, go back to run calculations, calculate, and when that's done, I'll be back. Alright, I'm back. We converged. That one took a little bit longer. 541 solutions converged. This is why it's good to set it to 1,000 instead of eliminating it to 200 or 300, because giving it more space to become more and more accurate is what we want. You see, we can actually see our drag coefficient there. It would make sense that our lift and drag are higher versus angle of attack, but you are going to get to a point where that kind of begins to decrease. But anyway, let's go down here to our contours here. Make sure we don't have anything selected. Display that. So as you can see now, our stagnation point kind of moved, as the air is approaching the airfoil at a different angle now. Our stagnation point changes because that's taking on the most pressure or whatnot. So we got our max velocity there, and then we have this cool little line kind of showing you, what would be happening behind of the airfoil at that angle. So sick stuff, man. And like I said, I'm gonna grab a picture of this to update my documents. Boom, boom, and then I'm just gonna show the static pressure contour. That's really what matters the most. All that other stuff, total pressure and whatnot, not big here. But if you do want to see what that's like, you just, you come in here, change that to dynamic pressure, and then you can see that. And then you get our total pressure there, like so. Focus on our static here. Alright, and then yeah, now we want our drag coefficient, lift coefficient. We already have these guys set up, so we hit compute, boom. Comparing that with the drag I got, pretty close. This is 0.02144. When I did this before, I got 0.02136. So once again, pretty similar there. Probably be different every time you initialize and run. So now for our lift, let's get that value. So when I did this before, I got 1.152. Now we got 1.151. So it's again pretty close. But yeah, that's pretty much it for this. Let's see, video showing how you get these plots in Fluent. Reynolds number, share a link. That's pretty much what I'm doing. All you have to do with this data is basically what I did. We go from varying 3 degrees angle of attack, and we start from -3, and then he specifically asked for 10, so I showed 10 in there as well. Take that, you want your CL over CD versus alpha, and then all I have left to do now is compare those plots with the XFLR5 results. But me and my group mates will be wrapping that up. But as you can see, everything over here pretty much matches the theory right there. Beautiful stuff. But yeah, that is pretty much it for this project. Thank you guys for watching. Hopefully this helps y'all out. If anybody watches this, I may or may not upload this in 2x speed, so we'll see. But yeah, peace out.